Before we begin our review of Newton's second law, let's take a minute and first review Newton's first law. The law focuses on two key parts. The first part is balanced forces. Balanced forces are those forces that when combined have a net force of 0. If we have 5 Newton force to the right or in the positive direction, and if we have a 5 Newton force to the left or in the negative direction, then we'll have a net force equal to 0. The second part of Newton's first law focuses on inertia. All objects have a resistance to a change in motion, but some have a greater resistance because they have more mass. It is harder to change the motion of a bowling ball than it is to change the motion of a soccer ball. Imagine trying to kick a bowling ball across a soccer field. Imagine a goalie trying to stop a bowling ball that's hit at him with such great force that he needs to catch it in his chest. Okay, so here we go. We have the first ball that has balanced forces acting on it. These two forces are equal. These two forces are equal. Therefore, this ball has a net force of 0. Newton's first law: an object at rest will remain at rest, and an object in motion will remain in motion with a constant velocity unless acted upon by an unbalanced force. The second law then starts to focus on unbalanced forces, those forces that cause acceleration. So if we take the example above and we double the force of the ball acting to the right, the ball will begin to accelerate to the right. Acceleration is a change in velocity. A change in velocity can be either a change in speed, a change in direction, or a change in both. This law connects force, mass, and motion through acceleration. Okay, the key ideas for Newton's second law of motion are that 1. Acceleration is the result of unbalanced forces. 2. A larger force makes a proportionally larger acceleration. If you double the force, you double the acceleration. If you quadruple the force, you will quadruple the acceleration as long as mass stays the same. The third key part is that acceleration is inversely proportionate to mass. If the mass increases, acceleration will decrease. If mass increases multiplied by 2, acceleration is cut in half. Let's look at Newton's second law through the idea of a boat. The boat has a motor, but the motor isn't turned on, and there are no other forces moving this boat. This boat will stay where it is until that force acts upon it. Let's say that it's just a father and his child in the boat going out fishing. If the motor is a 10 horsepower motor, that motor will be strong enough to move those two people along. However, if the father goes out and buys a new motor, and this motor is a 25 horsepower motor, there's greater force, so the acceleration on this boat will be that much greater than the acceleration on the first boat. Now let's say that not only are the father and the son in the boat, but also a cousin and even one more friend. The mass is now increased, so the acceleration of this boat will have decreased. Newton's second law tells us that the greater the force, the greater the acceleration. The greater the mass, the less the acceleration. Okay, in all of these examples, the motor was pushing the boat forward because that's the direction that the force from the propeller of the motor was being applied. If the father were to reverse the motor and the force were now to be applied in the opposite direction, this boat would accelerate backwards. The object will accelerate in the direction of the net force. There's one formula to use when looking at Newton's second law of motion. That is F equals ma, or force equals mass times acceleration. If you look at that numerically, then it would make sense that if you double the force, you double the acceleration. And if you were to cut the mass in half, you will cut the acceleration in half. Sometimes students get tripped up when you're given the force and you're given, let's say, the mass, but not the acceleration. If that happens, solve this problem algebraically. Take the time to go back into your notes and your textbook, and if you have questions, make sure you see me.